Recently, Mars has drawn the attention of everyone on Earth. You may have heard about organizations that want to travel to Mars. So what would that realistically look like for a regular person? In this video, let's discuss all of it in simple terms. Many organizations have already dispatched probes to Mars, and many more are preparing to do so. A popular motif in movies has also been the arrival of Martians on Earth. Yet the truth is somewhat different. The ones traveling to Mars and even capturing it are humans. How is the biggest concern right now? How will we survive long-term after we are there? The majority of the atmosphere on Mars is made up of carbon dioxide. The gravity is only approximately 38% of that of Earth, and the surface is extremely frigid. Any unfavorable circumstances for human life. Yet, they are modifiable. NASA has already made public its intention to take people to Mars by the year 2030, while SpaceX only intends to do it by 2024. Yet once we arrive, we can terraform Mars using cutting-edge modern technology and models. We shall talk about how we will survive and thrive on Mars in this essay. In the first portion, we'll discuss what originally occurred to the red planet before moving on to how we'll construct habitations, cultivate food, and take care of other essentials so that we can thrive on Mars. According to scientists, Mars was significantly different from how it is today. With water flowing on the surface, it formerly had considerably more favorable conditions for life. Some others even think there may have once been life on Mars. The planet's magnetosphere shielded it from solar radiation as the molten iron convecting in its core created a strong dynamo that transmitted magnetic waves out from the planet. It was a time when new volcanic eruptions began to create an atmosphere resembling Earth's. The heat that was contained allowed moisture to circulate throughout the planet as a component of the hydrosphere, supplying water for rivers to flow and possibly supporting life. However, after time, this magnetic creation ceased as a result of the planet's core cooling, leaving the panel exposed to the sun's unrelenting bombardment. The surface eventually became uncovered as the air was removed. As the ice in Mars melted, the water subsided beneath the Earth, leaving what is left of it today. But scientists have a model to restore the planet's lost magnetic. Although it's one of the trickiest approaches, 50% of all other issues might be resolved if scientists can find out how to use it. By locating a magnetic device at the planet's Lagrange point, we may augment the magnetic field. The Sun and planets' opposing gravitational pulls balance each other out, locking objects into a stable location between the two bodies. If enough magnetism can be produced at this stage, a path can be cleared for Mars to take refuge in, assuming that humanity are actually able to collaborate to fund, design, engineer, build, and use such a contraption. The atmosphere will begin to thicken and trap more air and heat as its magnetism begins to recover. The seeds of weather will soon start to appear as dense clouds rose over the Martian skies. Ice would initially predominate the cloud's contents, falling to the surface as snow or frost, but as the atmosphere built, water would finally condense in the air and fall to the ground as rain. The beginning of a water cycle will be established by this. We would eventually observe rivers and ponds flowing over the Martian surface. Scientists have also proposed another method for accessing water supplies. A solar-powered device that can extract water from the atmosphere at 20% relative humidity using a unique metal organic framework, MOF. With 2 pounds of MOF, this system can store around 3.2 quarts of water drawn from the atmosphere in 11 hours. Water can be made easily accessible on the planet with the use of such a system. Obviously, getting to Mars first would be the first step towards terraforming it. We have seen how NASA's landing technology has changed over the last few years. Many organizations are currently preparing to send rovers and landers to the red planet. They'll soon land people as well. But after arriving on the planet, scientists will investigate it to find ways to permanently settle there. What, However, are the recently put forth models? Well, NASA is already working on this issue, and various Mars home prototypes have been developed. These prototypes all share the premise that they will be self-sustaining, protected from thin atmospheres, and able to maintain life for an extended period of time. Martian space stations will be a challenge worth taking, much like the International Space Station, ISS, which has taught mankind a lot about how to exist in foreign surroundings. Power systems, docking ports, airlocks, and environmental control and life support systems are required so that crew members can go on spacewalks to fix things that break or provide new functionality. The journey to Mars will also be a long one. Astronauts will have psychological impacts, even though they have the necessary training. These prototypes are designed to accommodate this by providing more room for each astronaut. Simply put, the scientists aboard the ISS who were in space needed more room. Also, NASA has a plan to maintain the facility as an igloo. It is a building that resembles an inflatable inner tube and is also known as the Mars Ice House. It would contain elements taken from the planet and be covered in an ice shell. The rationale behind utilizing ice is that water is an excellent radiation shielding substance. One of the most significant problems to be solved on Mars will be radiation. Although the bases as well as suits will be upgraded. Acute radiation illness or even cancer can result from prolonged radiation exposure. Although we can also create subsurface bases below the surface, the ice base is preferable. Without making it appear like a cave, the sunlight will be able to enter. Mars is frigid because it is further from the sun than Earth. As was already established, because it lacks a thick atmosphere, unlike the Earth, it is vulnerable to radiation and the cold. It will take special dwellings with warm temperatures to support life on Mars and breathable air. Producing food on Mars would be another difficulty. The easiest method to make a habitat self-sustaining on Mars is to keep food and medicinal supplies stocked, but with a thin atmosphere and limited sunlight, it can be challenging to get anything to grow. Yet there are a few ways that researchers hope to cultivate food on Mars. According to research, some of the nutrients needed for plant growth are present in Martian soil. However, they must be grown in a restricted setting due to the extremely frigid temperatures. On Mars, nutrients may differ from one area to another, just like on Earth. Fertilizers would be necessary to make the solid rich in nutrients for the occupants. Fertilizers, which contain 5% or more of the essential plant nutrients, aid farmers in doubling or tripling their crop yields. These fertilizers also provide crops with nutrients that some soils lack. Specialists advise using manure or organic waste for this. Plants require carbon dioxide, which makes up the majority of Mars' atmosphere, in the same way as humans require oxygen to breathe. Moreover, research indicates that less water may be needed on Mars than it does on Earth for plant irrigation. This is due to the fact that water would flow through Martian soil differently due to the gravity of the red planet, which is around 38% more than that of Earth. As a result, the planet's surface will be able to store more water and nutrients than the soil on Earth. To provide future astronauts with fresh fruits and veggies, researchers are also creating sophisticated self-sustaining grow facilities. NASA and the University of Arizona are working together on one such project. The Bioregenerative Life Support System, or BLSS, is another name for it. In a hydroponic growing chamber, food can be grown without soil. Artificial ecosystems called bioregenerative life support systems are made up of numerous intricate symbiotic interactions between higher plants, animals, and microbes. It all starts with nutrient-rich water. The roots of the plants are supported by this nutrient-rich water. People and plants both profit from the system because the former release carbon dioxide, which the latter absorb. During the process of photosynthetic respiration, the plants in turn generate oxygen. Often, when we imagine a future for Mars, we picture greenhouses filled with plants and human civilizations colonizing the planet with cutting-edge technology. But those times are far off. Terraforming Mars will still take a long time. Scientists and astronauts will attempt to learn as much as they can about the planet during their maiden missions. Survival is a crucial ability for astronauts to acquire because it differs drastically from Earth. A habitat and a science lab will probably be part of the initial base. These modules' interiors will resemble the space station in many ways, but there will also be certain variances. Another danger to astronauts in space is microbiology. Scientists can't be certain that there aren't any harmful microbes that could endanger human life without more research. As the facility is created and the astronauts acquire the necessary survival abilities, things will become more exciting. The planet can then gradually be made self-sufficient in terms of resources and necessities. The harvesting of water and farming will begin gradually. Scientists will attempt to terraform Mars and make it habitable by using the methods listed above. Currently, many enthusiasts, including Elon Musk, are already striving to establish a permanent human settlement on Mars. Their aim is to send roughly 250,000 people there to do so. The first human on Mars will arrive in the following years, and a colony will follow soon after. The technologies will change and become more advanced. Yet, one thing is certain: space exploration has a promising future. What do you think of these human aspirations for visiting a new planet? What consequences and repercussions does it have on humanity? When will we be able to terraform it completely? Also, we must keep in mind that Mars will never truly resemble Earth. Let's keep in mind that our planet is unique in a variety of ways. Thanks for watching. Like the video and follow our channel to support the creation of more fantastic stuff like this.